All right, so this quiz is over two types of solving quadratic equations. The first one is solving by factoring. So you will have some that are already factored for you. And I'm just looking that you know that you should set the factors equal to 0 and solve. So when you have something like this, yeah, typically it is going to be the opposite, but keep in mind for something like 4, you can't just take the opposite. So you do need, what you're really doing is you're setting each one of these groups equal to 0 and solving. So you're just doing whatever you have to do to solve for that variable. So in this case, n could be 2 or -3. From there, you're going to have to actually start factoring. So I've pulled several different types of factoring. Just basic factoring, factoring out a common factor, and then where you have to multiply across. So for something like number 5, it has a leading coefficient of 1. So I really just have to say what's going to multiply to give me -6 and add to give me -5. Again, this is one of the most common mistakes made when factoring. This one is -6 and +1 that are my factors when I do that. And so again, once you have that, it looks just like the ones above it. Add 6 over, subtract 1 over. Something else that sometimes throws people off are the ones like number 7. If this were a special case, it would be a perfect square minus a perfect square. That is when you do plus minus of the same things. This is not that case. You really are just taking out the common factor here. The common factor between these two terms is just a v. And so if I take a v out, I just have v plus 6. And so now my two factors that I said equals 0 are those two. So I have v equals 0, v plus 6 equals 0, subtract 6. So my two answers here are 0 and -6. So looking at these, number 11, something that should stand out is that it does not equal 0. So if you find one that doesn't equal 0 before you start factoring, you need to make it equal to 0. So before I do anything on this one, I have to move that -2 over. So I'm just going to add a 2 over. Now I have n squared minus 2n. -37 plus 2 is -35. So to factor this, I am looking for factors of -35 that give me -2. So I'm going to say, well, that's n minus 7, n plus 5. -7 times 5 is -35. -7 plus 5 is -2. And so now it's factored, and I can just set my factors equal to 0. So n is going to equal 7 or -5. That's one thing you may see with some of your more difficult factoring is that you don't have it equal to 0. You need to have it equal to 0 first. If you come across something like number 13 and I am the one giving you the assessment, somewhere in your brain should say, Miss Waters probably is not going to make me multiply 4 and 112, right? So what do you think you probably need to look for here? Yeah, common factor. What does go into all of those? 4, all right? So the first thing I can do here is to divide that 4 out, all right? So 4 divided by 4, 12 divided by 4, 112 divided by 4. So when you do something like this, just do 11 divided by 4, that's 2, right? And then carry the 3. 32 divided by 4 is 8. So you can just do it a little bit at a time, or you can do long division over to the side if you want to. Once I have this, I did not pull out a variable. Had that been a variable, I would need to set that equal to 0 and solve. If I pull out just a constant, it actually doesn't affect my answer. If I were to divide both sides by that constant, I really just have to worry about the inside, factoring that guy. So two numbers that multiply to give me -28, but add to give me -3. That's going to be x minus 7, x plus 4. And then I'm right there at solving. Set them equal to 0 and solve. So 14, once again, is subtraction. But 6 and 96 are not special. They're not a special case here. But what should you look for here?
Common
A common factor. What is your common factor here? Yeah, I can take a 6 out. So if I divide both sides by 6, then I am going to have just a k squared and a 16. That is a special case. Again, I had taken just a constant out, so it really doesn't affect anything. Now I'm just looking at k squared minus 16. If I'm solving by factoring, then that is k plus 4, k minus 4. And by the way, part of what I'm grading you on is did you factor it correctly, okay? So you can't just jump straight to your answer here. I need to see that you solve by factoring if I give you those instructions. And then you can go to your answer. Of course, it's going to be -4 and +4. When I look at this one, I do not have a common factor between 3, 13, and 10. Also, I have a leading coefficient that is something other than a 1. So it means I cannot just look at factors of 10 that add up to 13 because you, 1, won't find them, right? And 2, we're forgetting that we have a 3 in front if we do that. So when I have something like this, I'm going to use the method where I pull that across and then I factor by grouping. So when I have something like this, I'm going to take that 3 and I'm going to multiply it by that -10. So now I'm looking for factors of -30 that give me +13. All right? Which means one's positive and one's negative, right? It's not going to be 3 and 10, right? Because that's going to give me the same sign to get 13 if I do 3 and 10. So yeah, this is going to be 2 and 15, right? So I need a -2 and a +15. I can double check this. -2 times +15 is -30. -2 plus 15 is 13. Those are the right factors, all right? So now I'm going to rewrite this with just replacing the 13k with a -2k and a 15k. I'm going to rewrite that problem. So I'm going to leave the 3k squared alone. I'm going to say -2k plus 15k to rewrite that middle guy. And I'm going to leave the -10 alone. All right. Now, how do I factor 4 terms? What is the process for factoring 4 terms? Factor by grouping. Yes, we put parentheses around them. So I'm going to put parentheses around the first 2 and parentheses around the second 2. And then I treat them individually. Common factor. So what's the common factor in my first group? Just a k. So between these 2, all I have in common is a k. So I'm going to take that k out. And I have 3, I took one of my k's, and I have that 2, and I took my k out. Don't forget you have a plus sign here or a minus, depending on what was there, so plus. Now let's look at the next 2 terms, between 15k and 10. What's in common between 15 and 10? A 5, so that's what's going to come out. 15 divided by 5 is 3, and I didn't take a k out. -10 divided by 5 is 2. If factor by grouping is going to work, these 2 groups must look identical when you do that process, all right? These 2 groups have to look the same. So now I'm almost there. My first group, 3k minus 2, I'll just write that down. My second group is going to consist of what is left over. What's left over is k plus 5. K plus 5. And now this looks just like my first page, doesn't it? Just like my first page that was already factored for me. So now I'm going to take the 3k minus 2 and set it equal to 0. And the k plus 5 and set it equal to 0. And now I just have basic solving. Over here I'm going to add 2 to both sides. I have 3k equals 2. Then I need to divide by 3k. Or by 3, because it's with the k. So I have k equals 2/3. Over here, I just have to subtract a 5. So k will also equal -5. So my 2 answers here are positive 2/3 and -5. the first thing you could come across is it's just something squared equals a number. Those are beautiful, right? In order to solve this, I am really just going to take the square root of both sides. So if I have this, I'm going to say we'll take the square root of both sides. If you take the square root of a square, like that variable, you have that. For the other side, if it's like this and has a perfect root, the square root of 25 is 5. But when I have a variable involved with my solving, I have to consider that it could be positive or negative 5. You are welcome to write plus or minus in front of your number if that's the case, or you can write positive 5 and negative 5, all right? But I have to consider that if I were to plug it back in, 5 squared equals 25, and negative 5 when you square it equals 25. That's why those are my two answers, okay? I could also have something like 24. Again, the variable is already by itself. I just need to take the square root. So I will have n, but 47, can I even factor him? No. I cannot. Now, if I could factor and simplify, let's say the other side was 12. That is actually factorable, right? We have 2 and 6, 2 and 3. So that's going to simplify to 2 squared to 3, but it's still not going to be a perfect number. So either way, I want your radical to be as simple as possible. But in this case, I'm just going to write it like that. 47 is as simple as possible. The answer is the square root of 47. We don't have a perfect root. And I still have to consider the fact that it could have a positive or negative root, just like 25. So that is my answer. You can't have special cases. So if I look at him, he's all by itself. We're going to do that. We have k equals the square root of negative 84. Can't take the square root of a negative. Why not? In real number world, anytime you square a number, what's going to happen to it?
Oh, it's a positive.
It's always a positive. So in real numbers, which is all you're dealing with on this quiz, if I said, what's the square root of negative 9, you would say nothing, because 3 squared or negative 3 squared is positive 9. So this guy looks like him. All right, that is empty set notation. You could also write these little words right here. But you cannot take the square of a negative number. Now here's the thing. On the next page, we have some multiplication happening in front of our numbers. So if you were to have a negative, you don't want to automatically assume that it's going to cause a problem. It could work itself out in the long run. So we'll do one specifically like that so you can see that. Here's the thing. You cannot decide if it is going to be a special case until you have that variable all by itself. So until you have the x squared or the b squared or whatever the squared may be, in this case k squared by itself, you can't automatically say, oh, no solution. So you don't want to look at this problem number 29 and say, oh, negative 82, no solution, because that's not necessarily correct here. I have to work out just the k squared by itself before I make that decision. So I'm going to do everything I need to do. I'm going to go ahead and add the 8 over, right? Over here, I'm left with negative 2k squared. On this side, negative 82 plus 8 gives me what?
Negative 74.
Right? So I have negative 74. Again, we're not going to stop. We do not have the variable by itself yet, right? So my next step then is to divide both sides by negative 2. On the left-hand side, I have k squared. What do I now have on the right-hand side? Negative 74 divided by negative 2 is positive 37. This is going to have a solution. It's not going to be an integer, but it is going to have a solution. So I'm now going to take the square root of both sides. On the left-hand side, I have k. 37 does not have a perfect root, nor can you simplify it with a factor tree. So it's just going to be this guy right here. So for 31, I want to get my n squared by itself first. So I'm going to add that 5 to both sides. I have 5n squared equals 95. Divide both sides by 5. We have n squared equals 19. 19 again. Looks like this. All right. Multi-step problems. Get your variable by itself first, then take the square root. All right, so we're going to do the same thing with this one. We're going to subtract our 2. We have 100p squared equals 36. Divide both sides by 100. Now, normally I would tell you to reduce. However, I'm about to take the square root. What do you know about 36 and 100? They both have perfect roots. So if I didn't have perfect roots, I would reduce my fraction, right? I know I'm about to have a perfect root, so I can actually reduce it at the end and it'll be smaller numbers. So you can go ahead and take your square root if you want to. Remember, the square root of fraction is just the square root of the numerator over the square root of the denominator. What is the square root of 36 and 100? 6 and 10. Do you think I'm done with this problem? I am not. What can I do with him? He reduces to what? To 3 over 5, right? Also, I took the square root involving a variable. What do I need to make sure I include there? Plus or minus, or either a negative 3/5. Yep, there you go.